Hey everybody, so here's a quick video on simplifying some more binomials, some more radical expressions. We're gonna do a little bit with exponential expressions too, so check this out. So here's something that's been baffling some of you guys. Squaring a binomial that contains a variable. So here's, for example, 2 plus the square root of 7x all squared. If I'm gonna square that, well, first of all, I'm gonna multiply it to itself. All right. The FOIL method is extremely useful. First, outer, inner, last. So I take my 2, multiply it by the 2. What do you get? 4. All right. I take my 2 and I multiply it to the square root of 7x. Well, those aren't like terms that can be multiplied. So I'm going to call that 2 root 7x. That's all I can do. Same with root 7x times 2. I'm going to get 2 root 7x. And then here's a funny one. Root 7x times root 7x. Well, I write it root 7x times root 7x. You can think of that as, if you want to complicate it, you can say root 49x squared. What's going to end up happening is that both of those are perfect squares. So a radical expression times itself, well, when you square it, the radical cancels out. So this is really just 7x. All right. So I've got 4 plus 4 root 7x plus 7x. All three of those are different terms. I can't combine anything. That's the end of that expression. Here's a useful bit of advice. You can, if you'd like, you can turn on your graph right here and take a look at the graph. Okay, so here's the graph of 2 plus root 7x squared. And as you continue writing expressions in Desmos, if they have the same value, then they'll yield the same graph. So that's pretty cool. All right. There's another example right there for you. What if I square with an expression that has a coefficient that's a variable? Well, I'm still going to use FOIL. All right. In this case, I can combine 2x root 3 plus 2x root 3, get 4x root 3. Here's something neat. X root 3 times x root 3. You're going to get, well, x times x is x squared. And then root 3 times root 3, we've decided that's just 3. So technically, that's going to give me 3x squared. That's pretty cool. All right. Radicals in exponential form. The fourth root of x is the same as x to the 1/4. X to the 4/5 is the same as the fifth root of x to the 4th. So we can say that the root of the radical is your denominator for the exponent, and the power for your expression inside of the radical is your numerator. All right, and that is a simple explanation of radicals in exponential form. If I'm simplifying radicals that contain variables, this is a review of a Math 1 lesson. First, I can break it up into factors. So this one, I would break it up into root 25 times root x to the 6th times root y to the 7th. You can change them into exponents if you'd like to. So, well, for example, root 25 is just 5. Root x to the 6th, well, technically that's x to the 6 halves because a square root has an understood 2 in the root. And I would have y to the 7 halves. Now, x to the 6 halves is just x cubed. So I got 5x cubed. But that y to the 7 halves, I don't think that's the most simple way to express it. So what you're going to want to do is really y to the square root of y to the 7th. You want to break that up into factors. Square root of y to the 6th times the square root of y to the 1st. That would give you square root of y to the 7th. So this first one, square root of y to the 6th, you can simplify as y to the 6th over 2, or y cubed. And square root of y is the square root of y. So final answer, 5x cubed, y cubed, square root of y. Takes a little time and it takes some practice to get good at that. All right. A tougher expression, what if I had the square root of 4x cubed, y cubed? Well, again, I break it up. Square root of 4 times the square root of, and look what I did with the square root of x cubed. I broke it up into square root of x squared times the square root of x. All right, that's technically the square root of x to the 1st. Same with y, square root of y squared times the square root of y. All right, and it all ends up boiling down to 2x to the 4th, y to the 4th, square root of xy. All right, last part of the lesson, simplifying. What if I have some negative roots, negative radicals? As long as you have a cubed root, you can have a negative under the radical. However, in the second example, I have a square root that has a negative. That tells you imaginary number. The square root of negative 25 should be factored to the square root of negative 1 times the square root of 25. The square root of negative 1, remember that that's I, so that would be equal to 5i.